Welcome to Step 2 Maths. In this section, we are going to discuss about how to solve simultaneous linear equation using Cramer's rule. This method is also known as determinant method. Question: 4x plus 3y minus 4 is equal to 0. 6x is equal to 8 minus 5y. Solve this equation using Cramer's rule. For that, first we have to rewrite the given equations in the general form of linear equation. 4x plus 3y minus 4 is equal to 0. This we can rewrite as 4x plus 3y equal to, on right side minus 4 become plus 4. 1 and 6x is equal to 8 minus 5y. This we can rewrite as 6x minus 5 become plus 5y equal to 8. The given two equations are rewrite in the general or standard form of linear equation. 4x plus 3y is equal to 4 and 6x plus 5y is equal to 8. How we can solve this using Cramer's rule? For that, we have to find the value of determinants d, dx and dy. The value of determinant d is equal to, take the coefficients of x and y. D is equal to 4, coefficient of x is 3 and coefficient of x is 4 and coefficient of y is equal to 3. For from equation number 2, the coefficient of x is 6 and 5. Now find the value of determinant 4, 6, 3, 5. First 4 into 5. 4 into 5 minus 3 into 6. 4 into 5 is 20 minus 3 into 6 is 18. 20 minus 80 is equal to 2. The value of determinant d is 2. Now find the value of dx. How we can find out the value of dx? For that, we have to replace the coefficients of x by constant. Here the constants are 4 and 8. So instead of the coefficients of x, we have to write the constants 4, 8 and coefficients of y are same 3, 5. Find its value. 4 into 5 minus 3 into 8. 4 into 5 is 20 minus 3 into 8 is 24. 20 minus 24 is minus 4. The value of dx is equal to minus 4. Now find the value of dy. How we can find out the value of dy? For that, we have to replace the coefficients of y by constants. When we consider dy, the first column is coefficients of x, that is 4 and 6. 4, 6 and instead of coefficients of y, we take the constants 4 and 8. Find the value. 4 into 8 minus 4 into 6. 4 into 8, 32 minus 6 into 4 is 24. 32 minus 24. 32 minus 24 is 8. Now we get the value of determinants d, dx and dy. Then we know the value of variable x is equal to dx upon d. The value of dx is minus 4 upon value of d is 2. That is minus 4 upon 2 is minus 2 and the value of variable y is dy upon d. dy is 8 and the value of determinant d is 2. 8 upon 2 is 4. So the values of variables x is equal to minus 2 and y is equal to 4. To solve a given linear equation using Cramer's rule, we have to find the values of three determinants d, dx and dy. Then x is equal to dx upon d, y is equal to dy upon d. Here we get the values of variables x is equal to -2 and y is equal to 4. Solve this simultaneous equation using Cramer's rule. The question, x plus 2y is equal to -1, 2x minus 3y is equal to 12. This equation is given in the form of ax plus by is equal to c. Next, how we can apply Cramer's rule? For that, we have to find the value of three determinants d, dx and dy. So, the determinant d is equal to, take the coefficients of x and y from two equations. From the first equation, the coefficient of x is 1, coefficient of y is 2. From the second equation, coefficient of x is 2 and coefficient of y is -3. When write down the coefficients, consider the signs also. Here it is -3. So, d is equal to 1, 2, 2, -3. Now, find the value of this determinant. 1 into -3, 1 into -3 minus 2 into 2. 1 into -3 is -3 minus 2 into 2, 4. -3 minus 4. -3 minus 4 is equal to -7. So, the value of determinant d is equal to -7. Now, find the value of determinant dx. How we can find out the determinant dx? For that, the first column, that is the coefficients of x, are replaced by the constants. So, these 1 and 2 are replaced by -1 and 12. The coefficients of y are same. 2, second column is coefficients of y, that is 2 and -3. Now, find the value of determinant dx. -1 into -3 minus 2 into 12. -1 into -3. -1 into -3 is +3. 3 minus 2 into 12 is 24. 3 minus 24 minus 21. Now, we get the value of determinant d, dx. Next, find out the value of determinant dy. dy is equal to, how we can write the elements of dy? The first column is coefficients of x, that is 1 and 2. 1, 2. In d, the second column is coefficients of y. And when we write down dy, instead of the coefficients of y, we are replaced it by constants, that is -1 and 12. Find out the value of dy. dy is equal to 1 into 12 minus -1 into 2. 1 into 12 is 12 minus -1 into 2 is -2. That is 12 minus -2. 12 minus -2 is 12 plus 2. 12 plus 2 is equal to 40. The value of d is -7, dx is -21 and dy is 40. Then the value of variable x is equal to dx upon d. Here the value of dx is -21 upon d is -7. -21 upon -7 is equal to 3. In the same way, the value of variable y equal to dy upon d. dy upon d, the value of dy is 14. 14 upon d is minus 7. 14 upon minus 7 is equal to minus 2. So the value of variable x is 3 and y is minus 2. The two given simultaneous equations are 6x minus 4y is equal to minus 12 and 8x minus 3y is equal to minus 2. Solve this simultaneous equation using determinant method. For that, first find out the value of d. d is equal to, take the coefficients of x and y, 6 and minus 4. From the second equation, it is 8 and minus 3. That is equal to 6 into minus 3 minus 4 into 8. 6 into minus 3 minus 18 minus 4 into 8 is minus 32. Minus 32. That is equal to minus 18 minus of minus 32 become plus 32. Minus 18 plus 32 is equal to 14. So the value of d is plus 14. Now find out the value of dx. dx is equal to, instead of the coefficients of x, that is the first column is replaced by the constants, that is 6 and 8 are replaced by minus 12 and minus 2. The second column is same as the d, that is minus 4 minus 3. That is equal to minus 12 into minus 3 minus 4 into minus 2. Minus 12 into minus 3 is plus 36 minus 4 into minus 2 plus 8. So it becomes 36 minus 8. 36 minus 8 is 28. So the value of dx is 28. What is the next step? Find the value of dy. dy equal to, from d, the first column is same as the coefficients of x, that is 6 and 8, and second column, that is coefficients of y, are replaced by the constants, minus 12 minus 2. Now find the value. 6 into minus 2 minus 12 into 8. 6 into minus 2 minus 12 minus 12 into 8 is minus 96. That is equal to minus 12 minus 96. It's become plus 96. Minus 12 plus 96. Minus 12 plus 96 is equal to 84. So the value of d is 14, value of dx is 28 and value of dy is equal to 84. Now the value of variable x is equal to dx upon d. The value of dx is 28. 28 upon 14 equal to 2. The value of y equal to dy upon d. Value of determinant dy. dy is equal to 84. 84 upon 14. 84 upon 14 is equal to 6. So the value of variable x is equal to 2 and variable y is equal to 6. 4m plus 6n is equal to 54 and 3m plus 2n is equal to 28. Solve this simultaneous equation using Cramer's rule or determinant method. First, find out the value of d. D is equal to, write down the coefficients 4, 6, and from second equation it is 3 and 2. Find out the values. 4 into 2 minus 6 into 3. 4 into 2, 8 minus 6 into 3, 18. 8 minus 18, that is minus 10. The value of d is minus 10. Now find out the value of dx. dx is equal to, the first column is replaced by the constants 54 and 28. The second column is same as on d, that is 6 and 2. Now find out the values. 54 into 2 minus 28 into 6. 54 into 2 is 108 minus 28 into 6, 168. 108 minus 168 become minus 60. The value of dx is minus 60. Now find the value of dy. dy is equal to, the first column is coefficients of x, that is 4 and 3. And second column, the coefficients of y are replaced by constants 54 and 28. 4 into 28, 112 minus 54 into 3, 162. 112 minus 162 minus 50. The value of d is minus 10, dx is equal to minus 60 and dy is equal to minus 50. The value of x is equal to dx upon d. The value of dx is minus 60. Minus 60 upon d is minus 10. Equal to minus 60 upon minus 10 is 6. Similarly, the value of y is equal to dy upon d. dy is minus 50 upon d is minus 10. That is equal to 5. Therefore, the value of xy is equal to 6 and 5. Consider these simultaneous equations. 2x plus 3y is equal to 2. X minus y upon 2 is equal to 1 upon 2. Solve these simultaneous equations using Cramer's rule. The first equation, 2x plus 3y is equal to 2. Consider the second one. X minus y upon 2 is equal to 1 upon 2. First, rearrange this equation in the form of ax plus by is equal to c. To change the fractional form, for that, if you take this 2 as common denominator, this become 2x minus y upon 2 is equal to 1 upon 2. If we multiply this equation throughout by 2, we can write it as 2x minus y equal to 1. This equation we can consider as the second simultaneous equation. This is the first one. Now find out the value of d. d is equal to 2, 3, and for the second equation the value of x and y are 2 and minus 1. 2 and minus 1. Find out the value of d. 2 into minus 1 minus 3 into 2. 2 into minus 1 minus 2 minus 3 into 2, 6. Minus 2 minus 6, that is equal to minus 8. The value of dx. Dx is equal to, the first column is replaced by the constants. Here the constants are 2 and 1. 2, 1. The second column is 3 minus 1. Find the value of this determinant. 2 into minus 1 minus 3 into 1. 2 into minus 1 minus 2 minus 3 into 1 3 minus 2 minus 3, that is minus 5. Now find out the value of dy. Dy is equal to, first column is 2, 2 and second column is 2, 1, 1, 2, 1. Take the constants 2 and 1. Find its value. 2 into 1 minus 2 into 2. 2 into 1, 2 minus 2 into 2, 4. 2 minus 4 is equal to minus 2. Now we get the value of d, dx and dy. Therefore, the value of x is equal to dx upon d. The value of dx is minus 5. Minus 5 upon d is minus 8. Minus 5 upon minus 8 is equal to 5 upon 8. Then the value of y equal to dy upon d. What is the value of dy? Dy is equal to minus 2. Minus 2 upon d is minus 8. 1 upon 4. Therefore, the value of variables x, y is equal to 5 upon 8, 1 upon 4. In this way, we can solve simultaneous equations using Cramer's method or determinant method. For that, first write the given equation in the form of ax plus by is equal to c. Then find out the values of three determinants, d, dx and dy. D is the first, for d the first column is coefficients of x and second column is coefficients of y. Dx is the first column, that is from the first column of d, that is coefficients of x are replaced by the constants. Here it is 2 and 1 and second column is same as the coefficients of y. Then find the values of determinant. Similarly, dy is, for dy the first column is coefficients of x and second column is the coefficients of y are replaced by constants. Then find its values, and x is dx upon d and y is dy upon d. Using this Cramer's rule, we can easily solve the simultaneous equations. Thank you.